Okay, this is the last section in the last part of section 4.1. We're going to be talking about finding C, because up until now, C has just had to be at the end of our equations. But we do have a way now to get that actual number. It's C standing for constant. We can find that constant number. So the process will start just how everything else started. So if we have this integral, y equals the integral of 3x squared minus 1 dx. Then we follow our power rule and we can integrate this function. So we would add 1 to the exponent, so 3x cubed over 3 minus 1x. We have plus c. So we can simplify that. The 3's can divide and we don't have to write that 1. So we have x cubed minus x plus c. This is all we've been able to do so far. The name of this, when we have plus c in our solution, this is called a general solution, because c can be anything at this point. It can be positive, it can be negative, it can be a fraction. So that's what we're looking at, what we've made so far. With enough information, we can get what's called a particular solution. A particular solution means that we're able to find what that number is. Is it a 3? Is it a 4? Is it a -2? Whatever that is. And we call these in general, when we have an equation that's been taken the derivative of, we call it a differential equation. It's an equation. Differential has to do with the derivative. It just really is saying that you have an equation that was taken the derivative of, you've undone it, all that kind of stuff. But these are just a couple of vocabulary words that you're going to see in this section. So we're going to have something called a general solution that has plus c. We're going to find a particular solution. So we're going to find c, and then we'll write our equation with c in it. All of these in general, this general category is called differential equations. What we need to find a particular solution is something called, another vocabulary word, an initial condition. So this is basically, where does it start? That allows us to find C. Okay, so what it's going to look like. We'll have given a couple different things. We're going to be given, or we're going to have to find our general solution. This is a general solution because we have plus c. This point, when they give us numbers, this is what an initial condition looks like. Sometimes they can give us an initial condition in an ordered pair. The x value is 2, so that would be 2. The equal to is the y value, so that would be 4. Either way, they're going to give you an x value and a y value. Whenever we have the number on the inside, we're going to be plugging this into x. And whatever number is like this is equal to 4. So we will literally set our general solution equal to that number. Okay, so what happens is we take that initial condition, f of 2 is equal to 4, and we take this equation. F of 2 means plugging in 2 everywhere we see an x. So this would be 2 cubed minus 2 plus c. And we're setting that equal to 4. So we're going to be able to solve this. 2 cubed is 8, minus 2 plus c is 4. 8 minus 2 is 6. So c is -2. So our final answer is not just -2. This is the c. If they asked for the constant, that would be the number. But just like our general solution is an equation, our particular solution is going to be an equation. So our particular solution, we take our general and plug in c. So our particular solution would be x cubed minus x minus 2 since it's negative. You can do plus and negative, but it's the same thing. So let's look at a couple examples of how to apply this. So example 1, we're going to find the general solution of the equation f prime of x equals 1 over x squared, and the particular solution that satisfies our initial condition of f of 1 is equal to 0. So remember, a general solution means it's our equation plus c. A particular solution means that we're going to find c. So c will not be part of our answer. We're going to have a number in that spot instead. So what we want to do, first, to find our general solution, we want to integrate. So we are going to set up our integral. So we're going to take the integral of our equation, which is 1 over x squared dx. To integrate this, we're going to have to rewrite it, x to the negative 2 dx. Then we can add 1 to our exponent. So if we add 1, we get negative 1. Divide by that number, plus c. And then we can simplify. This would be negative 1 over x plus c. And this is our general solution. Then we can take our initial condition, f of 1 equal to 0. So this went from f prime. If we integrate f prime, we're going to get f. So this was f prime. We integrated it. Now this equation is f. So we plug in 1, negative 1 over 1 plus c equal to 0. So we have negative 1 plus c equal to 0. So c is 1. Remember, our solutions are equations here, so we need to go back to our general solution and plug in 1 for c. So negative 1 over x plus 1 is our particular solution. So those are our two answers. We have our general solution and our particular solution. So let's look at this. It says solve the differential equation. So we're going to look at 2 where these are our directions. Well, if we're solving differential equations, this means finding our particular solution. So this time our derivative is 3x squared. This is our original. This is our initial condition. So even though this is dy dx, it's just telling us that that's our derivative. So we're going to integrate 3x squared dx. Make sure you can set up an integral symbol, dx at the end. That's important. So we have 3x cubed over 3 plus c, which is just x cubed plus c. So that's our general. We need to use our initial condition, f of 2 equal to 3, to solve this. So we're plugging in 2. So we have 2 cubed plus c equal to 3. So 8 plus c is equal to 3. So c is negative 5. So our answer, the solution to this differential equation, y is x cubed minus 5. Now a note about notation for differential equations. If we say we integrate our second derivative, well, integrating is taking away a derivative. So if we integrate f double prime, that would give us f prime of x. It takes away a derivative. If we integrate f prime of x, It takes away another derivative, so we would get f of x. We can integrate f of x, but we need notation. We can't just call that f of x. So what you're going to see, they'll change this lowercase f to an uppercase f. Technically, these are all plus c, but I'm just focused on the f notation. So if you integrate f double prime, it'll go to f prime will become f, lowercase f will become capital F. So that capital F just means that you've integrated. Okay. So let's look at our last example. We are solving this differential equation. Now, solving a differential equation means you need to get all the way back. You need to get all the way back to like something that's not a derivative. So in this one, we're starting at our second derivative. They give us two initial conditions, one for f prime and one for f. So when we see this, this is asking us to do the process twice. So we'll integrate and use this initial condition first, and then we'll integrate again and use our second initial condition to get all the way back to the original function. So the first thing that we want to do is we want to integrate f double prime of x, which means that we are going to integrate 3x to the negative 1/2 plus 12x minus 2. When we integrate that, we'll have 3x to the positive 1/2 dividing by positive 1/2, flip it in front, 2/1, plus 12x squared over 2 minus 2x plus c. So when we simplify that, we have 3 times 2 divided by 1, that's just 6. X to the 1/2 plus 6x squared minus 2x plus c. So if we integrated f double prime, that means this is f prime of x. Then we have to use our initial condition. Our initial condition for f prime is that we have f prime of 4 is equal to 93. So that means plugging in 4 to this equation. So that's 6. A 1/2 power is a square root. So we have 6 times the square root of 4 plus 6 times 4 squared minus 2 times 4 plus c is equal to 93. So the square root of 4 is 2. So we will get 6 times 2 is 12. 6 times 16 is 96. 2 times 4 is 8, plus c is equal to 93. So we need to subtract 12, subtract 96, and add 8 to 93. And when you do that, you're going to get negative 7. So our solution for f prime of x is 6x to the 1/2 plus 6x squared minus 2x. Instead of plus c, we have minus 7. Now we need to repeat this because we have another initial condition and we want to get all the way to f. So now we're going to integrate f prime. So we're going to integrate f prime of x dx. So we'll integrate 6x to the 1/2 plus 6x squared minus 2x minus 7 dx. When we do that, we have 6, we have x to the 3/2, which is 2/3 in front, plus 6x cubed over 3 minus 2x squared over 2 minus 7x plus c. So this is we integrated our first derivative, so this will be our original function, f of x. 6 divided by 3 is 2. 2 times 2 is 4. So we have 4x to the 3 halves plus 2x cubed minus x squared minus 7x plus c. Then we want to use our second initial condition. F of 1 equals negative 3. So now that we have f, and we need f of 1 equals negative 3. So we plug in 1. 4 times 1 to the 3 halves plus 2 times 1 cubed minus 1 squared minus 7 times 1 plus c is equal to negative 3. Now a 3 halves power means we're taking a square root and then we're cubing it, but since it's 1, it's just 1. So 4 times 1 is 4. Plus 2 minus 1 minus 7 plus c equals negative 3. So we need to subtract 4, subtract 2, add 1, and add 7. When we do that, c will be negative 1. So our f of x is 4x to the 3 halves plus 2x cubed minus x squared minus 7x, set of plus c minus 1. And that's our original function. We're all the way back to f. We've used all of our initial conditions, and that's it. So that's the end of this section.